Ganapati Panda sir. Professor Ganapati Panda is currently working as a professor and research advisor at Raman Global University, Odisha, Bhubaneswar, India. Professor Panda served as the Deputy Director, Dean Academic Affairs and Head School of Electrical Sciences at the Indian Institute of Technology, Bhubaneswar. He was also Dean Administration, Head of Electronics and Communication Engineering at the National Institute of Technology, Rourkela. He was a member of the Board of Governors of IIT Bhubaneswar and NIT Rourkela. Dr. Panda also served as Director of National Institute of Technology, Jamshedpur. He worked for 48 years in teaching and research in leading technical institutions in India. He did his postdoctoral research work at the University of Edinburgh, UK in 1984 to 86 and PhD in 1981 from IIT Kharagpur in digital signal processing. He has guided 42 PhDs in the field of signal processing, communication, artificial intelligence, and machine learning. He has published more than 463 research papers in 272 referred journals and 191 conferences with 13,423 citations, a index of 56 and ITIN index of 207 as of 18 January of 2024. 10 more PhD students are continuing their PhD work under his active guidance. He has successfully completed a number of research projects from various funding agencies in India and other countries. He is a fellow of National Academy of Engineering India and a fellow of National Academy of Science India for his significant research contributions to the signal processing and machine learning. He has received Samanta Chandrasekhar Award in 1993, Biju Patnaik Award in 2012, INAE Outstanding Teacher Award in 2017, AICTE INA Distinguished Visiting Professorship in 2019 and 20, and AICTE Margadarshak in 2019 and 20, Lifetime Achievement Award in Ravenshaw University in 2021, Senior Scientist by Odisha Bigyan Academy in 2021, and listed under top 2% scientists of the world from the Stanford University in the area of AI and ML in 2021, 2022, and 2023 for significant contributions to engineering, education, and research. His name is included in the Technology Advisory Board of the Center for Development of Telematic, Government of India in March 2022. Professor Panda is listed as one of the world's best computer science scientists in India by the Microsoft Academic Graphic in the year 2022 with a national rank of 33. He is a senior member of IEEE, Fellow of IIT, Fellow of IETE, Fellow of IE, Life Member of CSI, Life Member of ISTE, and a Life Member of System Society. He is a regular reviewer of many international journals. He has chaired and delivered keynote addresses at many international conferences in India and abroad. His research interests are in the area of artificial intelligence, machine learning, digital signal processing, digital communication, and intelligent instrumentation. Now I would like to welcome Professor Ganapati Panda sir to deliver his speech. Now it's up to you, sir.
Thank you. Thank you for introducing. Am I audible?
Yes, sir, you are audible.
Okay. Second, is the first slide is visible?
Yes, sir, your title is visible.
Okay. So, should I start now?
Yes, sir.
Should I start now?
Yes, sir. Please start, sir.
Okay. Thank you. Thank you for introducing me. Good morning to all the participants and the faculty members, research scholars who are present. Thank you for inviting me to deliver the first lecture on this FDP. It is a very interesting topic. I hope all the participants will enjoy it. Since it is my first lecture, I thought of delivering the very fundamental of this topic, which usually many speakers do not speak. Those who want to learn more in depth, I request the participants to contact me to know the more details. I'm an old man, aged 76 years, and I was at NIT Rourkela from 87 to 2009, 22 years. Thank you. Let me start. Yes, basically, my lecture will be 3 parts in 1 hour 30 minutes. In the first part, I'll cover intelligent computing. Second part, I'll go to deep learning, give an overview of deep learning. In the third part, I'll tell many applications and speak something on biologically inspired technique, nature inspired technique, etc. My group, starting from Rourkela, since 1987, we started about the artificial neural network, and slowly we have developed, and today we are working in the area of machine learning, deep learning, artificial intelligence applications to healthcare, communication, signal processing, finance, and many such important applications. About more than 200 SCI journal papers have been published on this topic. So you can search and find out. Basically, everybody talks of intelligent computing. We generally analyze the data. What is data? Data is plural. What is the singular of this? Datum. So data, when the amount of information, when the amount of raw information become very large, it needs to be analyzed. What are the sources of data in electrical engineering? Hundreds of sources, from transmission line, smart grid, transport, all types of fault, generation, protection. From all these sources, we get data in electronics, communication, telecommunication, image, video processing. Today we talk of IoT, we talk of healthcare, we talk of finance, and we talk of political data. Data is large in amount. They are raw. Very difficult to come to a solution what this data is meant for. Therefore, the data needs to be analyzed. 2 types of analysis. It should be online or offline. That I will come. Sometimes we want immediate decision. Sometimes we want let the decision take its own time. Decision making, reasoning, and arriving at a solution requires analysis of data. Am I clear? You have to take a decision. Human being cannot take a decision with less amount of data. Doctor cannot take. The weather forecaster cannot take. A financial expert cannot take. So data analysis of 2 types. 2 types of analysis. One is statistical analysis, operation research based, mathematical based methods. Secondly, intelligent analysis. The first type has a limitation, particularly, please remember, I tell very forceful word. If the data are correlated, if the data is non-linear, if the data is non-stationary, very difficult to analyze. Conventional method fails. Therefore, we have to go for intelligent data analytics. For achieving this intelligent data analytics, we have to do we have to use the help of computational intelligence, which comprises of artificial intelligence, machine learning, deep learning, fuzzy logic, evolutionary computing, artificial neural network, etc. Another thing, when the amount of data is enormously large, it happens in electrical engineering, particularly in grid system, protection system. The types of analysis has to be big data analytics, which is different from the conventional data analytics. So big data analytics is important also. Now, let us see steps of data analysis. We usually, most of our researchers fail to follow up these steps. Therefore, the result we obtain are not proper. Now, pre-processing of raw data, try to remember, pre-processing of raw data is very, very important. It comprises of generation of missing data, normalization of data. Data to be missing data can be created. Methods are there. Sometimes we miss the data during experiment, during recording, and those data to be recreated. Normalization of data. Some data is very small, small or very large. If all are fed to the model, they do not work. The small data effect is not considered. Therefore, data needs to be normalized before you process the data through the model to arrive at a decision. Next important thing is feature extraction. When the amount of data is large, directly if you use the raw data, the processor takes more time. Therefore, the data, from the data, the juice to be extracted, and that is called features. There are three types of features. I told you I'm touching fundamental thing. People miss this. Three types of features. One is statistical feature, like mean, variance, cumulant, higher order statistics. Second type of features are transform domain features. This comprises of discrete Fourier transform, first Fourier transform, wavelet transform, cosine transform, S transform, Hadamard transform, slantlet transform, and so on. Transform domain features are very powerful. From the raw data, first you have to extract any of these types of features depending upon the situation. Third types of features are technical features. If you are from electrical stream and trying to make some classification and forecasting of power data, transmission line data, then the technical aspect of those data has to be taken. If you are doing finance, the finance types of data, finance types of features are to be taken. So that is called technical feature. When all the features are accumulated, then amount of features become less. Therefore, features need to be reduced or features need to be selected. So there are two things. From raw data, feature extraction. After feature extraction, features reduction or feature selection. There are methods of feature selection. There are three methods of feature selection. Similarly, feature reduction, feature to be reduced. Why to reduce feature? To make the model simple, to make the model economical, to make the training of the model less time, make it less costly. Even though feature reduction reduces the accuracy of operation, the performance is reduced to some extent because you are not using all features. But besides, the complexity is reduced, cost is reduced, training time is reduced, product can be made. Am I clear? All this you must have to learn before roughly using these types of techniques. This is a very important slides. Yes. What are the types of decision? Operation selection. The whole of the world today, even political people are speaking of machine learning, deep learning. Why? It performs some particular sets of job. One is filtering, which is highly necessary to remove the unwanted information, to remove the interference, particularly for electrical. Clustering. In filterings, one of the dangerous things is harmonic and subharmonic. That needs to be removed if you want to purely handle the fundamental side of it. Clustering. Second one is a very important decision, grouping to take decision. You have to group the students, group the employees, group the performance, group the types of fault. What type of fault you have to group? Forecasting or prediction. Forecasting or prediction, very, very important. Weather prediction, fault prediction. Yes. Prediction is very, very important. Next one is classification. You have to classify what types of fault. You have to classify the types of voltage generation. You have to make a classification in case of different types of privacy. Classification is very important, particularly for cryptography. We want to make security classification, what types of attacks are being done has to be known. The next important one is parameter estimation, system identification, pattern recognition, direct modeling. These are same. In control system, we need to estimate the parameter. To find the fault, today we talk of 5G, 6G communication. We talk of different types of industry 4 standard, 5 standard will come. Now this requires the identification of fault. Where is the fault? Online manner, intelligent manner. So staying at a remote place, you can find what is the fault of the conveyor belt or a motor or a furnace. How to estimate it? This is a pattern recognition, computer people are saying. System identification is very, very important to make a sensor intelligent, to make an instrument intelligent. The other one is inverse modeling. Inverse modeling. The first one is direct modeling. Inverse modeling, also known as deconvolution, channel equalization, nonlinearity compensation. This we need in instrument, in measurement, in communication, in earthquake, and many of the application sensors. Sensor to make intelligent, you need to know the convolution. Two things I'm telling. Please remember, parameter estimation identifies or inform you the fault, whereas inverse modeling rectifies the fault. Yes, we have many papers, 15, 20 transaction paper, you can see. One is an instrument or a device or a system, whether faulty or not to know, you need to know parameter estimation. Inverse modeling will try to compensate, modify, rectify the fault. If these two combinations are kept, the system becomes intelligent or smart or cognitive. Next important information is optimization, maximization, or minimization. It can be of single variable optimization or can be multivariables. It can have, the function can have single objective or it can have multi-object. These variables can be with constraint or without constraint. So therefore today, the evolutionary computing, bio-inspired technique or nature-inspired technique are now dedicated for multivariable, multi-objective, multi-constraint optimization. Just a minute. Next one is detection, fault detection. In our healthcare, extraction of signal with a low signal to noise ratio. ECG signal, when you record, when you measure the heartbeat, then the signal level is very low. It is affected by mother's heartbeat, affected by power signal. How to eliminate that? So basically, how many things I told? Filtering, clustering, forecasting, classification, parameter estimation, inverse modeling, optimization, and detection. 8 things. There is no 9 things. The whole of data analytics, machine learning, deep learning, any companies are doing, any manufacturing industries are doing, whatever things you are reading and learning and using, they do any 1 or 2 or 3 of these decision-making operation. Am I clear? 8 things. There is no 9 things. So try to, any research, mostly today we do, I have seen, they do try to solve their, orient their problem, either a clustering problem or a forecasting problem or a classification or optimization problem. And they try to solve with the machine learning, deep learning. All these techniques can be solved by machine learning and deep learning techniques. Now question is, what are the different techniques available for this operation, to achieve this operation? Filtering can be, this is adaptive filtering. Filtering 3 types. How many types? 3 types. One is conventional filters, fixed filters. Second one, adaptive filters, which uses least mean square, recursive least square, back propagation learning. And these types of learning methods use derivative-based learning. I'll clarify later what is derivative-free learning and derivative-based learning. Feature reduction, principal component analysis, linear discriminant analysis. These techniques are also bio-inspired technique, can be employed to reduce the amount of features to make the product simple. clustering. Clustering, various types are there. K means clustering, hierarchical clustering, fuzzy C means clustering, and so on. These clustering techniques are used for grouping the data. These are, remember, unsupervised. Automatically clustering can be done. The difference between K-means and hierarchical clustering, K-means or fuzzy C-means, you assume that the total amount of data belongs to 2 groups, 3 groups, or 4 groups. Whereas hierarchical clustering does not assume the data to belong to 2 groups or 4 groups or 6 groups. Automatically the data is grouped into the desired number of groups. That is better method than K-means cluster. Coming to forecasting, prediction, regression is used. Logistic regression, nonlinear regression, but these are statistical method, machine learning method. They are not so powerful, but people are using. It is not nonlinear operation. Nonlinear regression has come, but has a limitation. So those who want to do research, please do not use these old techniques. Coming to nature-inspired technique, there are more than 50 techniques that come, starting from genetic algorithm, particle swarm optimization, and so on. Yes, today more than 50. Every month, some technique is being published. These techniques are population-based learning. It is a distributed learning. It takes time, but it's a derivative-free learning. Nature-inspired techniques are very powerful. It's optimal solution. However, it takes more time than population-based. So today, the future research is how to develop distributed biologically inspired or nature-inspired techniques. There are various types of artificial neural network also used for forecasting and prediction. Then a set of artificial neural networks starting from perceptron multilayer, the real basis function, functional artificial neural network. Today, what is the development? What is the latest thing in artificial neural? It is really not interactive. I usually like to have an interactive session. Please remember and write down spiking neural network. Actually, the model of the neurons in the brain are not this conventional neural network we are using. There are hundreds of varieties, but they are not the true model. The actual things that happens in the brain between the communication from one biological neuron to another biological neuron is through spikes. The distance of the spike, the height of the spike are the intelligence. I will tell you little more details. Classifier, all types are Hello? Am I audible?
Yes, sir.
Any problem? Hello? Any problem?
No, sir, you are audible.
I should continue.
Yes, sir.
Yeah.
Yes, sir.
Please tell me any problem. Question is, what I said now, artificial neural networks are developing day by day. But the future of the artificial neural network, we started last 10 years, spiking neural network, saffron model, Sresan model, and so on. Try, if you are doing anything on forecasting, prediction, classification, try to use SNN. Classification, I told, similar technique, but there are other techniques like in Embase, decision tree, random forest, support vector machine, and so on. There are more than 30 machine learning techniques which are used for classification. My question to you and to the society, why so many methods are coming? Obviously, some method has some defects. So to alleviate the defect or limitation, new methods are coming. But still, we are not able to achieve our targets. Particular, when the data is less, particularly when the data is correlated, non-stationary, very difficult to do classification. Parameter estimation, as I told, pattern recognition, all types of biologically inspired technique, neural networks, LMS, RLS can be used. But two things I'm putting before you. Remind me if I forget. Derivative-based learning. Other is derivative-free learning. Derivative-based learning, like LMS, RLS, backpropagation, falls to local memory. To alleviate that, nowadays people are using bio-inspired technique, derivative-free learning. But it is time-consuming. It cannot be used for online purpose. In burst modeling, same techniques. Deconvolution for the earthquake, to know what the strength of the earthquake, the process is deconvolution, inverse of convolution. In communication, when transmit some information and receive in the receiver, the signal is distorted, image is distorted, video is corrupted. How to get back the original information? That process in the receiver front end, you have to put a channel equalizer, which will try to compensate the wrong thing that is done during the transmission of signal. It is an inverse model, channel equalization. Optimization, I told, this techniques is a completely new area. I'll show a few of these slides, one my research scholar has recently done. Detection is very, very important. When submarine is inside the water, how to detect? When the SNR is very low, how to detect the type of fault? Yes, robust detection is very, very important. There are techniques by which it can be obtained. The another thing which has come to the world is distributed learning. We worked in NIT Rourkela, I remember, towards 2008-9, distributed learning, incremental learning, diffusion learning. Instead of collecting all data into a central point and then processing, which is conventionally being done nowadays, takes more time. Transmission of data to a central place. Then processing by a very large computing system. Once you get the result, again send back to the individual place. Come to agricultural phase, sensor network, IoT, cloud computing is. Banks, hundreds and thousands of banks are communicating for finance matter, agriculture, finance, healthcare. 500 hospitals are there. In some hospital, few patients, but unless you have large number of patients, you can't be using machine learning method. for prediction of disease. Therefore, distributed learning is the future. My suggestion to all the participants who are particularly researchers, try to learn what is distributed learning without sending the data. Data will be in their local place, but you can use small data. Solution will not be correct, but the solution will be cooperated, and you get the global solution. That is what incremental learning and division. I told very, very powerful sentences. I just touched the points. Today, robust distributed learning, federated learning, with less amount of data transmission is the future. Try to study in your own field of research. Try to learn this and use this. Yes, can I give a 1 minute gap? Please wait for 1 minute.
Yes, sir. Yes.
Yes. Yes. Let me talk about systems. Whether it's an electrical system, mechanical system, electronic system, or any system. System can be fixed. Whether a motor, whether a generator, whether a transmission line system, whether a grid, whatever the performance you are getting, we accept it. You design, for example, a filter I design, and whatever the filter, low pass, high pass, or mid pass is giving, I'm to be happy. Not correct. But the input situation changes. What? Temperature change, voltage, environment, and internal condition. All the changes reflect poor performance. Second is aging problem. Nobody considers. Same filter, same motor. In the beginning, it is performing well. After 5 years, after 10 years, when there is aging, the performance degrades. Due to voltage change, temperature change, humidity change, the instrument behavior changes. Are you following me? How to compensate these types of wrong performance? Always the system, whether new or old, whether low temperature or high temperature, whether voltage change, frequency change, but the system performance will not change. That is called intelligent system. Adaptive system can adapt, but adaptive system cannot find the fault. Intelligent, smart, or cognitive system today, first it detects the fault. Second, it rectifies the fault. Then that system, instrument, sensor, control, automatic, that all is intelligent. I'm not in front of you. You could have really appreciated by when I would have given some example. Intelligent system development today, smart system development today is very important, but people do not follow it, do not understand the griefs of it. Talks a very big thing.
Updated faculty list.
Yes. Any question? I'm continuing.
Yes, sir, you can continue. Sir, you are muted.
Is it visible?
Yes, sir, visual.
Oh, sorry. Okay,
Yes.
let's talk of computational intelligence. Please remember, a lot of people confuse. I ask a lot of questions. First thing, what is artificial intelligence? What is computational intelligence? What is soft computing? What is machine learning? What is deep learning? What is evolutionary computing? Bioinformatics? Lot of confusion. Actually, I thought of taking 1 hour class on that. But anyway, I'll tell the core fundamental. Computational intelligence comprises of 3 things. How many things? 3 things. First one, different types of artificial neural network. There are, as I told, more than 30 types of artificial neural. 30 types. What is the latest one? Spiking neural network. And in deep learning, you have got convolution neural network and so on. Recurrent neural network, radial basis, functional link. To my knowledge, with all modification, 30 types of artificial neural. Why? So many types. Confusion. Which one to be used? Why to use? Yes. The whole problem is, in our brain, we can able to decide correctly, remember correctly. So the biological neuron model, still today, nobody is able to make correct model. Artificial neural network model, multi-layer wrong, functional link wrong, radial basis, we are solving, but they are not the model. Today, the most closest model of the biological neuron is spiking neuron. That is, the neuron to neuron, they are connected through axon. There are 3 things: synapse, dendrites, axon, nucleus. These are few things you have to learn. And the communication, all are intact, interconnected, massively, parallel, distributed system. Very powerful sentence. And this neuron to neuron actual communication in the brain is what? Spikes, impulsive. The height of the spikes and the duration, how fast because spike to spike distance, that actually the intelligence. Can I tell 1 minute on this? The future is, please remember those who are enthusiastic researchers who are attending our faculty, when it becomes September, somebody is September, somebody is cool, the spike height and spike distance matters. So you can make a certain research going on in neuroscience, along with the doctor, along with the psychologist, along with the engineers. How to make a cool person a short-tempered person, or make generally the reverse. How to make a short-tempered person a cool person. How to make a slow learner a fast learner. How to make a dull student an intelligent student. It is possible. With an artificial device connected to the brain, it is possible to make a slow learner a fast learner. I could have given 2 hours talk on this. I'm working on this new field. Currently, I have how many? 14 research scholars. 45 completed. 4 are working. So 4 of the people are working on the area of neuroscience, spiking neural net. Can you make a slow learner a fast learner? Can you make a short-tempered person a cool person? Can you make a dull person an intelligent person? All the answer is yes. Thanks to the study how the spikes are generated, how the spikes are propagated, how the spikes sometimes doesn't generate. what happens? If you can suddenly worried, the amount of spike and generated and pass through neuron to neurons are different, distribution is different. Now, the types of learning. How many types of learnings are there? The neurons learns, the neuron trains, intelligence goes in. This happens in our artificial neural network. Weights, coefficients of parameters are changed with the help of learning algorithm like backpropagation. Backpropagation learning is a derivative-based learning. It has some limitation. When the number of layers will be more, BP doesn't work. There are many issues comes. When the problem is a function is a multimodal problem, artificial neural network fails. Therefore, you have to go same neural network and be properly trained with the help of derivative free learning instead of backpropagation learning. Very, very important. One is supervised learning. Teachers is teaching. You are reading books. When you are small, that parents teach. That is supervised learning. A cook helps you to learn how to cook, supervise. Some company helps you to learn driving, supervise. But without the help of cook, without the help of a company, without going to school also you can learn. That is unsupervised, powerful learning. But a mixed, semi-supervised, blind learning, reinforcement learning. You do something, makes mistake, and from your mistake you learn until you are perfect. Yes, that is also possible. Today, if you want to do most of our research work, publication we do with supervised learning, not that. For supervised learning, you should have a set of old data, known data. Therefore, you have to go for unsupervised learning or blind learning, reinforcement learning. Learn the word reinforcement learning. Should I give an example? Yes. There are 10 rooms in a building. 10 rooms. And 10 rooms in a building. And I put some food in some of the room and tell a cat, I leave a cat in the veranda. You'll find after half an hour, the cat goes to the room where the food is available. How he knows? That is reinforcement learning. Reinforcement learning must learn and must use. There is no time for me. We have done a lot of work on reinforcement learning. So these types of learnings are very important. This is a types of supervised, unsupervised, and semi-supervised. Similarly, I told you distributed learning. Incremental learning, diffusion learning. There are third types of division, third types of learning. Yes, these types of learning create hybrid learning. Hybrid learning. Now these, some of them are offline, some of them are online. You have to understand. And again, in distributed learning, supervised, unsupervised, or semi-supervised. I thought of 2-hour talk on learning itself. Similarly, on computing, before I go to this slide, computing. What are the types of computing? Yes, gentlemen, all young people, please listen. Quantum computing. quantum computing, federated computing. Yes. Then distributed free computing. Generative. Is it audible? Yes, anybody is listening. Is it audible?
Yes,
Hello?
Yes, sir.
yes, sir, it is audible.
Audible.
Yeah, okay. Let us say, I'm not going to the types of computing. That itself is a awesome. Yes. Now, regarding fuzzy logic. Yes. Are you saying something? Some sound is coming. Fuzzy logic. It is another brother of artificial neural network. Fuzzy logic. I'll give an example. Today the weather is cloudy in Rourkela. Fog is there. Temperature is less. There is mild rain. A driver would drive at what speed? His car is different from whether it is warm, no fog. Same car, same driver will drive in a higher speed. Fuzzy logic will tell you at what speed. Today, under this bad condition, you should drive. Fuzzy logic will decide and tell you this. I'll give another example. Washing machine today are available with fuzzy logic control. The dirtiness in the cloth will be sensed by the sensor, and accordingly, the temperature of the water, accordingly, the amount of water, the amount of detergent has to be given so that the cleaning will be different. When there is less dirt, what is the necessity of giving more detergent, more temperature? Therefore, the fuzzy logic in washing machine is a solution. Hundreds of problems are being solved by fuzzy logic. There are how many types of fuzzy logic so far? How many types? 3 types. One is Tagaki Suyano, TS fuzzy. TS fuzzy was developed in 1985. It is based on if-then rule. If-then rule. If today temperature is cool, I should drive slow. If today temperature is medium, my speed should be more. If today it is warm, I should put AC and drive fast. So these if-then rules are the basis of TS project. Solve very difficult, complex problem. Second one is the Mamdani project. It started by Mamdani and Esselian. They proposed one new types of fuzzy logic. You have to fuzzyfy and then defuzzyfy. So there is a for fuzzification, you have to convert the data into non-linear form. The types of conversion to fuzzification, the nature will be triangular, Gaussian, trapezoidal. Therefore, these types of conversion has to be made before you make the rule, and finally you have to deconvert, defuzzify. So you use a fuzzifier and defuzzifier. But the third one, the most important one, started being used in 1990 by Davis and Barrett. It is a rock fuzzy. In India, ISI Calcutta, Indian Statistical Institute, there is a group of professors, a few of them have retired, are in Pal. Few of them are really expert in the field of rock fuzzy. Those who want to use a combination of neural network and fuzzy logic It's called neurophagy. And try to use rophagy instead of TS and non-nephagy. There is no time, as I told in the beginning, each slide, 4 hours lecture, 2 to 4 hours lecture I can give in depth so that you can able to appreciate, use in your learning. This is another area. Biologically inspired technique, nature inspired technique, or evolutionary component. Their name is same. These are distributed learning, population-based learning. It has few advantages. It gives global, try to give global solution. It actually mimics the behavior of birds, animals, insects, human beings, ant colony optimization, bacteria, cat swarm. Till today, there is more than 60 techniques have come. It can be single objective. It can be multi-objective. Few research have come. Maybe 10 or 12 multi-objective biologically inspired techniques have been published so far. I told you, it solves multi-variable, multi-constraint, multi-objective optimization. What is the disadvantage? Takes more time. Not possible for online, but offline. You are using for a washing machine, for a controller, for aeroplane landing, for detection of a signal, for ECG recording. You are trying to analyze a person is having heartbeat or not. You have to be done instantaneously. Biological inspired technique fails, but research are being done. Research are being done to make it distributed now. So today, distributed genetic algorithm, distributed PSO, distributed cat swarm, and so on are the future. Try to make it distributed. Use in your research, you can publish in transaction paper. Yes. I'll give few examples. Those who are working in communication, you can use for spectrum management, channel estimation, classification of wireless signal, multi-objective routing, resource allocation, massive IoT management, autonomous drive, drone guidance, traffic prediction, multiple radio access, handover forecasting, demand side management, in microgrid, power generation, protection and control. Particularly in protection, you need to be done online, not offline. Therefore, these techniques have to be judiciously used. Distributed learning, machine learning are the future to be used for such application where few work has been done and reported. So decision making, I told this I have already. Not go to intelligent computing. This, as I told, is a vast area. On this, few of the, I thought I'll give example of genetic algorithm. I'll make you learn PSO, particle Bart's behavior. Yes, people are using extensively Bart's behavior. And particle swarm, update the velocity, they update the position and solve the problem. Each one I could have spent 5 minutes. Next one, the Billy has two behavior. Yes. In 2007, Billy algorithm much powerful than PSO. This algorithm use the Billy actually wait somewhere and observe. Suddenly a mouse runs, it starts following it whenever there is a food. So this seeking and tracing behavior, seeking, search for food from a corner. You can't say a cat is where, but he'll be inside somewhere under the tree, maybe under the bed or inside. Suddenly something, danger come or good thing comes, starts running. That is tracing behavior. It is much powerful than particle swarm optimization. Ant colony. Today, for traffic management, for all types of railway transportation problem, when you are trying to find the minimum path, particularly used for communication, IoT application, and colony optimization, very, very powerful. And colony, very. Each one I used to talk to my student in NIT Bhubaneswar, NIT Rourkela, I was teaching this. We have done work on exchange rate prediction. Yes, in the NIT Rourkela. Yes. And there are about more than 150 journal ACI paper. I'll share this paper list. We have applied to more than 20 fields. You can see from 11 onwards, prior to 11, more than 150 papers more. And after 11, we did a lot of research, all these things are there. Now, I'll give a gap of 1 minute. You have about 20 more minutes. I'll go to another 2 slides, show you what are those things. Just wait for 1 minute. I'm loading another slide set.
Okay.
Yes. Hmm. Is it visible?
Yes,
Hello?
sir. Visible. Yes, sir.
Okay.
Visible.
Visible,
Okay.
sir.
Yes, yes. This convolution neural network is one of the fast deep learning methods. Please listen, I'm talking very powerful sentence. I asked many people, I don't get correct answer. Why deep learning? What is deep learning? Okay. Now the conventional neural network. Conventional neural network has a limitation. We feel that when the number of layers are more, you are training. We feel backpropagation is training the weights. Yes. But the weights are not getting trained after some iteration. That is derivative-based learning problem. So basically what you do, we make dropouts. Some of the neurons drop out. That is an ad hoc solution. So there are some effects. And this, to alleviate this thing, new methods have come. But deep learning, basically I told you in the beginning, from the raw data, we extract features and then we reduce feature. And reduced feature is back to the model. Why should we do? By reducing the feature, accuracy will be lost. But times taken for training will be reduced, cost will be reduced, you can make a product. Therefore, feature extraction, and we don't know the feature we extracted is correct or not. To alleviate this problem, deep learning has come. Deep learning, particularly CNN, the first few layers are convolution layer. And the convolution layer the input sequence is done convolution with filters. And by doing so, features are generated. Convolution is incorrect. Convolution reduces the feature, generates the feature. Convolution is set of convolution, generates better and better feature. Just like imagine a tree, you get first the stems, roots, then branches, then leaves, and from the leaves the veins. So these are micro features. Features are extracted automatically. So the botheration of extraction of feature is not there in the plant. That is the first advantage. You need not bother when the amount of data is large, like image or video. Features are automatically extracted the first few layers of convolution. But in case of convolution, yes, for example, there are many images are there. Whether a big of a bird is present in the picture, which is there at a particular location, you can able to find out. That is the peak identification. Yes. So you have to search the image and you have to do high resolution segmentation. So you have to slide from left to right, a small window, down, left to right, continue until you detect the peak. And for that, the features of the peak is different from the feature of other portion. So that is what the exact features will detect the peak. So remember in CNN, first few are feature extraction. Last few layers are classification, whether it is a big or not a big, whether it is a bad, not a bad, whether this person is Mr. X or not Mr. X. So you can use it. Basically, yes, we can detection of this big. You can use CNN. Basically, big detector you can design. Just an example. Now the question is, in convolution neural network, convolution, what is convolution? Basically, suppose there is a picture 6 by 6 with a pixel value either 1 or 0, that's a black and white. And we have a filter of size how much? 3 by 3. So do the convolution, first put them. There are two filters. Let us take filter 1. Yes. Now filter 1 is chosen. So basically I put the filter at the corner. So this, first I took a window of size 3 into 3. Filter is of size 3 into 3. I multiply the corresponding component. That is 1 into 1, 0 into minus 1, 0 into minus 1, and so on. I get 9 multiplication values. Add them. I get 1 value. Then slide the window right side by 1 position. If I slide the window by 1 position, I call it stride equal to 1. I shift it by 2 position, stride is equal to 2. So I calculate in this way, this multiplication of 9 values and addition gives to 1 value. I continue left to right, then 1 step down, left to right, and so on, until I get 3. The first one is 3, second one I do minus 1, and so on. Finally, I get, basically, if you complete these slides, shifting by 3 by 3 and 6 by 6, I get a size 4 by 4. There is a reduction in the size, first thing. And this is the first convolution out. I continue with the same filter. There is a size reduction, and this reduced size Gen is nothing but your features. These are features. It's a two-dimensional feature. In video, three-dimensional. And in speech, ECG, power signal, we get one-dimensional features. Feature reduction. So basically 6 minus 3 plus 1. 6 minus 3 is 3 plus 1, so 4 by 4. Now the question is, when the picture is large, 500 into 500, after these types of convolution size diminished, but that is not adequate. Takes more time, hours and hours for feature extraction. And to achieve, reduce the time, basically what is done is pooling. Pooling is, we reduce the dimension. And I'll give you an example. Yes. So this I did for 2 filters, so 2 sets of data, I got 6. Then we hide is 1, shifting by 1, I told. Yes. If there are colored image, 3 colors are YB, so obviously that is 3 sets are convergent. Yes. 1 for R, other for Y and P. Next is this convolution. After it is fully connected. Fully connected. So we get it like this. Now, if you make into 2-dimensional convolution output as a 1 dimension, to make it fully and each one is representing the features of the image, and then use the last 2 layer or 1 layer as classifier to detect the big. Fully connected. Actually, it takes more time. So basically, another thing which is very important. Yes. Please see, to take the cat dog, whether it is a cat or no cat, then you do fully connected. Then first you do convolution, then you use pooling. Pooling reduces the size, but pooling does not distort the information. There are 2 types of common pooling: max pooling, average pooling. In case of max pooling, from that convolution output, take the maximum value and drop all the values. From the 9 values, choose the highest value, drop all the values. By this, there is a loss of information, but there is a substantial reduction in the computation time. So after each convolution, you follow maximum pooling or average pooling. In case of average pooling, you take the average of the 9 values, the 3 by 3 convolution output, sum divide by 9. So these types of convolution followed by pooling and so on, finally you get the best feature, and the best feature is used for classification, prediction, or parameter estimation or any such. So this is, I'm not spending time on this because this is I wanted to tell you how many types of, here one thing try to remember. Pooling is nothing but subsampling. The big picture becomes small picture. Are you finding? So that the performance will improve. Speed, to enhance the speed, pooling is used. Pooling in other name is subsampling. Yes. This is a separate talk. So basically what I want to say, that CNN is a fast time. The advantage of deep learning, the feature extraction is automatically done. And last layer is used for prediction, classification, or any such tasks. So basically it is a hybrid technique. Hybrid. First part for feature extraction, last part is for feature for classification, whether a person is having heart disease, whether it's a blood cancer, whether a person having tumor problem or glaucoma problem, you can detect. Just wait, please. I was telling about different evolutionary methods. I think NIT Rourkela should call me sometime so I can teach these methods in a interactive, better method so that everybody can pursue research. Evolutionary methods. I made a complete list. These first few ones of GA, who published which year and what the paper has done. You see here, GA. Is it audible? Audible?
Yes, sir, it is audible. Audible. Yes, sir, audible.
There are 20, 30 types of GA. Which year it was developed? Who developed? What the paper contains? These are all GA. Genetic programming. We have done on differential evolution, another powerful technique. Who did? What modification they did? Which year they did? So this is a in-depth analysis. Form intelligence technique. And colony, PS, B system, fish system, bacterial, all I have covered. Very extensive work. These are an idea about which year, which work has been done on different evolutionary algorithms. I'll show publication. See, for last 3 to 4 years, I'm focusing on healthcare. So I'll show you publication on few of our publication. Oh yes, please see here. I'm a retired person. Yes, and this from just in the last 3 years, when I 18 to 24, just a minute. Just wait. Just wait. I wanted to share my recent publication in healthcare and anyway, this just a minute. My publication I'll send to the coordinator and the coordinator. 3 coordinators are there. In healthcare, I have more than 70 papers in last 3 years at CIW. Similarly, in other activities, in communication, finance, in power system, and other techniques. So this is some of my paper in recent years, 2018. Is it visible?
Yes, sir, visible. Yes, sir,
Yeah.
visible.
So those who want to work in healthcare, please contact me. Many of you must be working. We are working on 15 diseases heart disease, then cancer, glaucoma, yes, tumor, varieties of disease. On speech, we do a lot of work. All papers mine are ACI paper. We do not do anything. And they say, these are papers you can see. I'll send you to the coordinators who will distribute. On COVID, we did more than 10 papers, 15 papers. All are ACI journal papers. This is first thing. The other publication, just wait. These are on healthcare. These are all last 4 to 5 years after my retirement. I'm in CV Raman Global University advisor. Yes. In the meantime, let me tell, till today, there are about 20 deep learning algorithms. 20. And I have made a list, actually, separate talk for the deep learning algorithms. Basically, this comprises of generative adversarial network, CNN, deep belief network, deep recurrent neural network, reinforcement learning. Yes. So there are many types of autoencoder. These are some of the publication I want to show. Okay, go to the deep learning. Just the last one. So this is, I'm not able to cover because time is not there, but I'll show the slides. Yeah. Different types of deep learning I want to show. First one is this CNN. Recurrent neural network. Very interesting. LSTM, long short-term memory network. Generative adversarial network. When the amount of data is large, not sufficient to train, artificially data can be generated and then passed through deep learning. This is what generative adversarial network. Today for image processing, today for video processing, you require the data is sufficient, not sufficient, you require these types of deep learning. Radial basis function. Their perception. As organizing maps. Tested that was my nation. I believe in it. Autoencoder is very, very interesting. Autoencoder. So this is an overview of some of the deep learning model. Just before ending, 3 things I want to do. When the challenges for research, I'm telling to all participants, when the amount of data is small, you can't train. Second, when the data is imbalanced, suppose 100 patients are there, 50 are having heart disease, 50 are not having. Training is very easy. But when 70 are healthy, 30 are disease, difficult to classify. Imbalanced data classification, most of the machine learning methods fail. How to solve the problem? Which are the methods which is very prone, which are very useful for this? This is one thing. Secondly, less data. Yes. Third is, you want the training to be faster. So there are some issues and challenges. And this you need to understand. Since it is my first lecture, not possible to cover all this. But if those issues which are now not yet solved can be addressed, and then your paper will be published and you learn a lot in time. So any questions quickly? Couple of questions in chat box. If you can say 2-3 questions, I can answer. Yes, organizers. So in the chat box, if you people can.
Hello, sir. May I ask a question?
Thank you, sir. If any query from the participants end.
Hello.
Sir, please tell.
Yeah. Sir, I want to ask one very basic question. Like, could you please enlighten what is the basic difference between machine learning and deep learning? I mean, when to switch to deep learning and when to go with the traditional machine learning scheme?
What is the machine learning versus deep learning? Just
Yes, sir. Yes, sir.
please listen. Am I audible to you?
Yes, sir. Audible.
Yes. See, machine learning can be of two types. Machine learning can be statistical, can be intelligent. First, machine learning, there are again three types: supervised, unsupervised, and semi-supervised. Third things, machine learning is dedicated for classification, prediction, parameter estimation, online job. Machine learning, you have to feed the features. From the raw data, you have to extract features and features to be injected to the machine learning model. Machine learning cannot produce features. Without proper features, if raw data is given, performance will degrade. Therefore, machine learning, if you want to use, you have to first extract features. Your features may not be correct, and based on the feature, the performance will degrade. Whereas in case of deep learning, automatic features are extracted in the first part, and the extracted features are injected for classification or prediction, etc. in the second part. So feature extraction is done and fed to the classification model in deep learning, which is not the case in machine learning. Machine learning is faster. Deep learning takes more time. Deep learning takes more times of training, hours and hours. Machine learning, limited performance, feature extraction variation, but learns fast. Performance is less. There is no time. I can talk for half an hour, but these are the fundamental thing you must learn. Any other question?
Okay. Thank you, sir.
Okay, so any other queries from the esteemed participants?
I'm audible.
Yes, you are audible.
Yeah. So I will highly appreciate the lecture that has been delivered by sir. Sir, I would like to ask one question that, as you said, that ML technique cannot be applied for small data set. So can you tell the how much small the data will be? Means, is there any cutoff value which should be taken care of? Cutoff value means number of data. How much at least should be there for applying ML technique?
Yes. Just answer. 1 minute.
Sir, you are muted, sir. Sir, you are muted. Kindly unmute yourself.
Listen. When the amount of data is small, none of the methods, deep learning cannot be trained. Machine learning can be trained to some extent. Are you following? But no satisfactory training. Deep learning fails. Machine learning can be trained, but performance will be poor. In fact, I didn't talk of training. Training is of 3 types. One is 70-30, 80-20. Third one is K-fold. No time for me to explain, but with small amount of data, training is poor in both cases and more bad in case of deep learning. But how to handle in any real life situation, data is small. Artificially, data can be generated. So generative artificial intelligence is a new area. Your 50 face to identify is not sufficient. So you have to make 500 face. So another faces can be created artificially. And after the data becomes sufficiently large, then effect. Could you follow 2 things? ML can be trained, but performance is poor. Deep learning cannot be trained. Solution is you have to artificially generate more data to make it appreciable for effective training. Okay. One more question. No question.
Okay.
Sir, in continuation with
Yes.
that, I would like, if I have 100 data sets, can I go for ML? Am I audible?
Yes, you are audible. Please be louder, madam.
Yeah, so I would like to know that if I have 100,
Hello, gentlemen. Are you able to listen me? 100 data you cannot quantify like this. For image and video, you want more data for the model to be trained. Question is whether your problem is a classification problem or whether it is a prediction problem. What problem? Your
if I have a prediction problem,
what problem?
prediction problem, if I am solving.
This is. Question is training should be perfect. Then only prediction accuracy will be more. Second problem, if you are short, you are predicting for tomorrow or day after. Accuracy is good, but predicting after a month, weather prediction, what will happen after a month, performance of all models are poor. Now the machine learning, how many class? If it is a classification problem, it is a multi-class. The 100 data is not sufficient. And if it is 100 data, what type of data and how many days ahead prediction? If you tell, I'll tell 100 data is ahead, but to me, 100 data is not adequate even for machine learning, for effective, achieving effective, successful, proper training. Any other question?
Sir, with continuation to that, I want to ask one more. Like,
Any
what
other
is how
question?
to?
And you can send to me. If any quickly, any question, because I
Sir,
have another
Actually, sir, we are running out of time. So, okay, just if you want having any question, please write it to sir. We'll share the mail ID of Professor Ganapati Panda, sir. So, it's possible, please, you can directly write him. Okay, sir.
thank you.
See, I'm ready to help old man. It is not
Yes.
interaction ground to ground,
Yes.
but we are a group at this age also.
Yes.
I'm still affecting every year more than 20, 30 ACI paper my group is publishing. So those want to learn and fundamentally strong in the country. So if you want to really learn, please contact me. I'm glad to help you. This is my last part of life. So whatever I know, I will distribute. Thank you.
Thank you, sir, for your nice and very beautiful presentation to all of us. Okay, thank you, sir.
Thank you. Another thing, hello, before
Yes, sir.
starting one thing, for sustainable computing. Yes, green computing. I didn't say, I'll tell 1 minute. See, always machine learning and deep learning consumes more time in training. So obviously the electrical, the hardware, the computer, yes, everything is remain with you. If you can make it faster training, faster testing, faster validation, feature extraction faster. If you make it less complex, but still accuracy is not diluted, perhaps that will consume much less power. So today, distributed, federated learning of these techniques, if employed, you can achieve the sustainable green computing method. Thank you.
Thank you, sir. Thank you very much
Thank you.
for your valuable time. Thank you, sir.
Thank you. Thank the organizers, 3 trio, who were coordinator and organizing and giving me a chance to share my views with you. Thank you.
Thank you, sir.
Right.